Hey everybody. So if you would hop on over to your Chapter 5 table of contents, I'm not exactly sure which lesson number we're on, but whatever the next one is, if you would write combining radical expressions and then add today's date. So back in Math 1, we used a few different exponent rules. We had the product rule, which said, hey, if I've got two of the same base, x to the whatever power and x to the whatever power multiplied together. I just realized I made a typo on this. X to the a times x to the b is equal to x to the a plus b power. All you got to do is add those exponents. For the power rule, this says, hey, what if I have something raised to a power, but then I go ahead and slap another power on that? So a power to a power. Well, you just multiply those exponents. So x to the a to the b gives you x to the a times b power. And then I guess I fixed my typo over here because now I have x again. So the quotient rule says, what if I'm back to two of the same base and I'm dividing them? X to the a divided by another x to some other power. We'll just subtract the exponents. So these two are pretty easy to differentiate, adding versus subtracting the exponents. How you know you're working with the power rule is if you have just one base with two exponents applied to it. So we introduced those back in Math 1, but now we're going to use them again that we know that radicals, square roots, cube roots, etc., are a type of rational exponent, meaning a fraction. So we want to use this to combine and simplify some radical expressions. So for number 1, I've got the cube root of x to the 5th times the cube root of x to the 5th power. Well, what I'm going to do here is rewrite both of these as their fractional exponents. So the cube root of x to the 5th power would become x to the 5 over 3. And then the cube root of x to the 5th power would become another x to the 5 over 3 power. 5 on top, 3 on bottom. 5 on top, 3 on bottom. Well, now that I've got two bases with two exponents, they're the same exact base, so I can just add them together. And then this one is set up to be a little bit easier. 5/3 plus 5/3 gives us x to the 10/3. Just make sure that you've got common denominators because they were both over 3. We were able to combine it pretty easily. Okay, and then all we got to do is say, hey, if we want that in simplest radical form, that fraction does not reduce. So we'll go ahead and put it back as radical, bring the 3 out as the index, and your final answer is that breaks down to the cube root of 10. So to recap, turn it to a fraction exponent, turn that to a fraction exponent, here and here. Then we add those exponents together. 5/3 plus 5/3 is 10/3. That does not reduce, and then put it back in radical form. Isn't it kind of weird that when you multiply a cube root and a cube root, you didn't actually multiply the exponents, you just added them? Let's try that again. Now the next one's a little bit trickier. We've got the square root of x to the 3rd power. Well, that one is going to be x to the 3 over 2 power. Multiplied by the 4th root of x squared would be x to the 2 over 4 power. Now we can add those exponents. Well, here's the deal. 3 over 2 and 2 over 4, they are not common denominators, so we can't add them just outright. We need to make them common denominators. The easiest thing to do is say, hey, 2 and 4, well, I could just double this fraction. So double the 3 to get 6, double the 2 to get 4, and then you can add them and say 6 plus 2 is 8 over 4. Now, does that fraction reduce? Yes. And weirdly enough, it reduces and divides out completely cleanly. So, we're done. There is no simplest radical form. this is the simplest radical form because there's no radical. I mean, I think you can all agree that being able to completely eliminate a square root is the easiest thing to do. Okay, let's try the next one. So the cube root of x to the first power would become x to the 1/3. The square root of x cubed would become x to the 3/2. So we're going to get to the point where we can add those exponents. However, 1/3 and 3/2 are not like terms. Or they don't have the same denominator. So the least common multiple of these two guys is 6. So if I multiply the top and bottom number by 2, I'm going to get 2/6. And if I multiply the top and bottom number over here by 3, I'm going to get 9/6. And so I've got 2 plus 9 is 11/6. That does not reduce, that does not simplify. So I can go ahead and say, hey, that is the 6th root of x to the 11th power. Okay, again, go ahead and change both of these to the fraction version of the radical. So the 5th root of x to the 4th power, the 4 goes on top, the 5 goes on bottom. So that becomes x to the 4/5 power. For the next one, 6 goes on bottom, 2 goes on top. We get x to the 2/6 power. Now, the least common multiple of 5 and 6 is 30. So to multiply, or to get the 4/5 to be something over 30, multiply them both by 6 to get 24/30. To get 2 and 6 to be over 30, multiply the top and bottom by 5 to get 10/30. So, oops. Didn't hope that wasn't too loud. So what we went ahead and did was 5 on bottom, 4 on top, 6 on bottom, 2 on top. And the rule says, hey, whenever I multiply two of the bases together, I'm supposed to add their exponents. But because they're fractions, I have to have a common denominator. So I found that by saying, hey, the denominators can both be multiplied to 30 to make 5 equal 30 multiplied by 6. So we multiply the top and bottom by 6. For the bottom of 2/6 to be 30, we had to multiply by 5. So multiplying the top and bottom numbers by 5 gives us 30. And the reason that I want to multiply the top and bottom numbers by the same number is because, for example, 4/5. If I multiply 4/5 by 6 on top and 6 on the bottom, see, I'm doing this so that I have an unsimplified fraction, so I have common denominators. But the calculator is not going to know that, and that's going to give me back 4/5. Because multiplying it by 6/6, 6/6 is just 1. When you multiply something by 1, nothing changes. So that's why I've kept just multiplying the top and bottom by stuff, because I'm not changing the value of these fractions. I'm just changing the look of them. 1/3 is the same thing as 2/6. 3/2 is the same thing as 9/6. 6/4 is the same thing as 3/2. And all I've been doing is just kind of changing the look of the fractions so I can add them. For this one, 24 plus 10 is 34. Over 30 plus 30, you don't add those. It's just 34/30. Now that fraction can be reduced. And your calculator will do that for you if you'd like. To get that fraction template, you hit alpha, y equals, and select the first option. That gives me 17/15. So I'll go ahead and rewrite that as the 15th root of x to the 17th power. Make sure you simplify those fractions if at all possible. Number 5, the 7th root of x squared would become x to the 2/7. The 4th root of x cubed would become x to the 3/4 power. Now, I know I spent a lot of time just talking about those common denominators, but our calculator can handle this very, very easily. All I got to do is say 2 over 7 plus 3 over 4 using those fraction templates. Not only will it go ahead and find a common denominator, it will add those and simplify. So the simplest version of adding those two numbers together is 29 over 28. So 29 is the power, 28 is the index. So our answer is the 28th root of x to the 29th power. Please, please, please feel free to use your calculator to simplify those fractions. Do not spend all of your days and all of your nights finding common denominators when your calculator will just do it for you, okay? Okay, type 2, the power rule. How we know we've got the power rule is whenever we've got an exponent that has another exponent, but here we're choosing and we've got two different fraction exponents. Well, all we've got to do is multiply them. And to multiply fractions, you just say the top times the top and the bottom times the bottom. So x to the 1/5 to the 2/3 power is just 1/5 times 2/3. We don't have to find a common denominator here, y'all. We just multiply them. 1 times 2 is 2. 5 times 3 is 15. 2 over 15 does not simplify. So 15 is the index, 2 is the power. The answer is 15 times the square root of 2. Or, gosh, I don't know why I just said that. Is the 15th root of x squared. I'm sorry, my brain decided to take a little vacation there for just a minute. For the next one, 2 times 6 is 12. 3 times 5 is 15. Now, hey, that fraction can be reduced. So it's imperative that we do that so that we have our simplest radical form. 12 over 15 will reduce down to x to the 4/5 power. So that will become the 5th root of x to the 4th power. So do definitely make sure that you simplify those fractions before you go ahead and rewrite it as a radical. Okay? Now, the nice thing about 6 and 7 is that we already had them in fraction exponent form. On the back, 8, 9, and 10 have not been quite so generous. So what I need to do first is I've got the square root of x cubed raised to the 1/2 power. I need to turn this into a fraction exponent, and that would be x to the 3 over 2 power. And then raise that to the 1/2 power like it already was. Okay? So at this point, I can go ahead and say 3 times 1 is 3. 2 times 2 is 4. That fraction does not reduce. So call that the 4th root of x cubed. Next one. The x to the 1/4 on the inside is already a rational exponent. But this cube root business, that needs to be written as 1/3. There's no power outside here other than the 1/4. And so we just say it's 1, and then 1 on top, 3 on bottom gives us 1/3. We're going to multiply those exponents together. 1 times 1 is 1. 4 times 3 is 12. That does not reduce. So go ahead and throw that in as the 12th root of x, or 12th root of x to the 1st power, whatever you want to say. For number 10, we've got the 5th root of, the 4th root of x squared. My goodness, why is life so mean sometimes? Okay, so let's go ahead and take care of this first. The 4th root of x squared could be rewritten as x to the 2/4 power. But then we've got it inside of this 5th root. Well, That is the fifth root of all of that to the first power. So let's rewrite that as x to the 2/4 to the 1/5. And now that it's both of those radicals have been turned into fractions, we can multiply. 2 times 1 is 2. 4 times 5 is 20. And hey, 2 over 20 is going to reduce down to 1/10. And so that would be the 10th root of x, or 10th root of x to the first power, whatever you want to call it. So to summarize that one, because I know it was a lot, we said the 4th root of x squared is really x to the 2/4 power. And hey, honestly, at this point, if you wanted to simplify that fraction first, more power to you. You go for it, okay? Well, then we said, hey, it was still inside of that 5th root. Well, the 5th root of anything is raised to the 1/5 power. And so we had that 2/4 and 1/5 multiplying together. If you didn't simplify it here, you're going to have to simplify it here anyway. So it doesn't really matter if you do that first or last. I went ahead and simplified it at the end and then said 10 is the index, 1 is the power. So we've got the 10th root of x to the first power. Okay, for this last set, the quotient rule. I know I've got the quotient rule whenever I've got something divided by something else, and the quotient rule says subtract. Well, I'm going to need to rewrite these as rational exponents. So on top, the cube root of x to the 7th is x to the 7/3. On the bottom, the cube root of x squared is x to the 2/3. Then I need to subtract. Make sure you say the rational exponent on top minus the exponent on the bottom. 7/3 minus 2/3. If you get that backwards, you're going to get the question wrong. Now these guys already have common denominators, so I'll go ahead and subtract and say that that is x to the 5/3 power. Well, 5/3 will simplify down to the cube root of x to the 5th power. For number 12, we've got the cube root of x to the 5th. That would be x to the 5/3. And then we've got the 4th root of x squared. That would be x to the 2/4 power. So I know I'm supposed to subtract and say x to the 5/3 minus 2/4. It is completely up to you if you want to reduce 2/4 and then unreduce it, or find common denominators and say, hey, 3 and 4 could both be a 12. So to make 3 a 12, you multiply by 4, so the top becomes 20. To make 4 a 12, you multiply by 3, so the top 2 times 3 is 6. And then 20 minus 6 is 14. Which would then reduce down to x to the 7/6, which gives us the 6th root of x to the 7th. But honestly, y'all, I hate that common denominator stuff. I just don't want to do it. And I feel a little bit ridiculous taking all the time to do that whenever I could just throw it into the calculator and say 5/3 minus 2/4. Boom, it gave me 7/6. I could go ahead and just say, hey, the 6 is on bottom, the 7's on top. So let's see if we can speed that process up. Number 13 was kind enough to give me 5/2 as a fraction already. So I just need the fraction on the bottom. The cube root of x to the first power is x to the 1/3. So 5/2 minus 1/3. I'm going to go ahead and throw that into the calculator. And it says that the simplified version of that is 13/6. So the 6 is going to be the bottom number, and the 13 is going to be the top number. So since 6 is the bottom number, that's the index, that would give me the 6th root of x to the 13th power. Okay, number 14, we've got the square root of x to the 7th. So it's going to be x to the 7 over 2 power divided by x to the 1/3 power. Now I'm going to go ahead and just type 7 over 2 minus 1 over 3 into my calculator. 7 over 2 minus 1 over 3. Hit enter, and it goes ahead and gives me 19 over 6. I can skip straight to the radical and say the 6th root of x to the 19th power. Okay, number 15. The top would become x to the 5/3 power. The bottom would become x to the 9/2 power. So 5/3 minus 9/2 comes out to negative 17 over 6. Now wait a minute, wait just a minute. X to the negative 17 over 6 power. Yeah, that's going to throw me for a little bit of a loop here, because those 3 exponent rules that we had on the front of our paper are 3 of the 5. There's 2 other exponent rules that I didn't put there. One of the ones which has literally no bearing on our lesson today is that x to the 0 power is 1. Well, that has nothing to do with today. But the other one says, hey, if you have a negative exponent, you're supposed to put that on the bottom of a fraction to make it positive. Okay? And if it was already on the bottom, you put it to the top and make it positive. But the idea here is that here there wasn't a fraction, so we say it was and then flip it. So we have to do that here. Okay? None of these others have come out to a negative exponent whenever we subtracted. And I am like 99.999% sure that your assignment after this won't either. But I just want to go ahead and show it to you. So this one would become x to the 17 over 6 positive on the bottom of a fraction with a 1 on the top. And then we can rewrite it as 1 over the 6th root of x to the 17th power. And I'm refusing to circle that answer because technically it's right and it is perfectly acceptable to write it like that. But tomorrow in the next video, we're going to talk about what might else we have to do with that. Okay, it's not that bad. But just know that really we're not going to want to have negative exponents here because we don't want to have a radical on the bottom. It's just some weird math nerd law as to why. But for now, this is totally fine. All right, please check your Canvas for your next assignment and head over to Delta Math and work on that. And let me know if you have any questions. Y'all have a good day. Bye.